Thank you for sharing. Very interesting. Most of the cities in Asia in particular, 94% of the buildings are old stock, very old buildings. Maybe the challenge for CTBUH is retrofitting, repairing, restoring. There's 94% old buildings. It seems we are more focused on the new buildings coming up. Yeah, thank you.
This is probably one extreme of what you have been saying. The Carlton Ritz Hotel in Hong Kong, it was a 110-meter tall building. 13 years passed from the inauguration of the building, opening ceremony of the building, till the demolition, because it was not able to compete on the market anymore, and it was designed as a hotel building, and now offices were needed in that area, and they were unable to transform the building and to adapt the building to cope with the new functions. So 13 years is an extreme, but it's happening more and more often.
Yes, I have a question for Mr. Sarkisian. So you showed life cycle assessment results of several buildings, but in your calculation, did you took into account the end of life of the building? So Mr. Trabucco showed us that it's a quite important part. So did you made it, and if yes, how did you make this calculation?
Really not the end of life. We considered that those projects could be repairable. Okay, so in that calculation that we included for all of those buildings, if they were in seismic regions that we would expect damage over their 50-year life, that was included. But in no case did we say, we're going to take the building away and completely replace it. So, I mean, I think what Dario is mentioning is a very important part of the entire equation, really. And in fact, I'm learning something from this today, because it's inevitable, right? It's a question of timing. Yeah. So, not included yet, but definitely something that we need to consider. Yeah. Thank you.
Dario, great presentation. The bit I disagree with is that 5% of embodied energy going into transport is not important. Actually, I think that's a pretty high statistic. I don't think that's a low statistic. 5% of the embodied energy going into a whole structural system in transport, I think that's a very high figure, personally. I know what you're saying about the 50 kilometers, that it's all in the last bit, but I think there's room for efficiencies in that.
Yeah, just a note on that. That 5% includes also the end of life of the building. So actually the materials are transported twice, once for construction and once for recycling. So if we just stop the analysis at the construction phase, it's probably half of that.
Question for Don, Mark, David and Dario, because it's applicable to all of your presentations, which I found, as I said, very interesting. LCA, we acknowledge, is an evolving science. However, how would you perhaps include in the impact category the issue of ecosystem loss or ecosystem disturbance or ecosystem destruction? For the very reason we are losing through ecosystem destruction, we're losing ecosystem services that are the very basis of our life: water filtration, fresh air, etc. One example, of course, which I've learned at this conference, is in Luxembourg. They have the largest steel production in the world. The feedstock is 100% recycled iron. In Australia, we're very, very much the source of iron ore. The ecosystem destruction is mind-boggling. I'd be very interested to see how you feel that we could develop a valid category in LCA modelling. Thank you.
My biggest one, which I think you also pointed out, that's a very open-ended topic that is very difficult to get your arms around. It's one of the reasons I was advocating that sometimes the best progress forward with LCA isn't in trying to compare materials, because obviously if we talk about timber, the ecosystem challenges in the environment outside of the urban built environment, road production, the cutting of trees, forest practices, are significant. If we're talking about a downtown urban environment building that is all largely being built out of recycled material, and if we're talking about steel as an example, it's a very different set of boundary conditions. And so I don't have an answer, honestly, on total ecosystems, other than I think there is significant value in how we represent the information of overall reductions. That's one of the things I liked about the SOM presentation, about once you have a baseline, how can we improve and just bring that baseline down based on the base materials that we have.
You hit on a point that I think is really important. It's water. In fact, I think water is going to be the next major challenge for us. I think we're already challenged. But the use of clean water and these systems and so forth needs to be quantified and considered, because that impact is very substantial. I'll say that my goal is that, and I'm going to call it self-sustainability, that our buildings and our cities are self-sustainable. So it may be something that comes in 50 years or 100 years, but my goodness, we need to be thinking about self-sustainability. So, buildings with umbilical cords that are tied to other systems, if we can make them go away, it's very important to us in design and how we might impact cities. So when we talk about ecosystems, I think that's a goal that I think is really super important for us to think about. How can we make our buildings self-sustaining, right? And it goes all the way through use, reuse, use of waste, you name it. It's all out there. So I think that's a significant challenge for us to consider.
Hi, this is Payman. My question is from Mark and especially from Ron, because both of you have a great experience in Bay Area. And the LCA is a very hot topic these days. My question is, did any of you consider the Bay Bridge, which is now under process of the dismantling? Because I know we are looking at the tall building, but that's also is a very complex, bridge, and considering the life cycle and also the process of the dismantling the bridge, how to consider all and utilizing after that. There's still.
I got nothing to say about the Bay Bridge.
I'm going to fall short here on the reference, but somebody wrote something recently about this, and it was really, I think, a very challenging position on the environment and the reuse of the existing bridge and what it would mean, whether it was reused in place and the new bridge was constructed. But the argument was very, very strong and very convincing that, in fact, even if we kept the bridge, the one that is currently there, and reused it for various purposes, from anything from residential to open space or whatever, the impact on the environment would be far less than what it's going to take just to take that bridge down. So, yeah, I mean, there's some creative, it's not my idea, it's just something that's out there. There's some really creative positions, and it challenges us to think about it in a different way. I mean, we quickly get at the demolition. My goodness, the demolition of that existing bridge is very, very significant in terms of environmental impact. Yeah. So anyway, thanks for bringing that up.
Hi, I'm Hisan Choi from Toronto, my city. I actually have a question to structural engineers, but more like to the developers here as well. We're talking about life cycle assessment for tall buildings, and especially with the area 500 meter plus buildings we can consider as permanent monumental towers. And as a structural engineer, we've been asked to optimize the building system, especially for floor system. If we are design, most of the tall buildings are residential floors, buildings to like 50% is minimum. If we design for minimum live load for residents, which is like half of office requirement, do you think our 100 plus story towers will be permanently used as residential only? So I think we have to consider design a building with a minimum live load requirement so that building doesn't have to be fixed as a residential or hotel. Instead, this building can evolve with the times so they can be used as studio, it could be office. Who knows, in 100 years from now, it could be something else. So I think we have to consider minimum live load requirement for our tall buildings, so that it can sustain longer. And also building structure system as well has to be studied as well. So I'd like to know, have you ever studied or considering study building systems that we have to promote in this business, or maybe we should tell them avoid some structure system for tall buildings? Personally, post-tension is a great system for me, but I don't recommend that for tall buildings because you cannot drill the punch holes easily. So that's my question and suggestion as well.
Just as a general comment, I'm actually thinking about the presentation I gave at the last CTBUH conference here, which was based on the longevity of buildings. And one of my points in that is that many times we talk about a 50-year design life. If we just change our mindset and talk about 100-year design life solutions, especially in the tall buildings, our choices of systems greatly change. And I especially in taller buildings, I think that's a very worthy conversation. Depending on the part of the building, even if, say, we're talking about 100-year design life, the cladding system probably only has a 20-year design life. And so depending on the component of the building, you're mentioning floor systems, but I think it takes a very thoughtful and knowledgeable owner that to work with the design team, and it's our job, frankly, to educate them, but we need to look at each of the components in different ways. And the best way you add longevity to a building is adaptability over time. So your post-tension comment is an interesting one as well.
So Olivier Vassa from ArcelorMittal. I have a question for Mr. Hermens. So as steel producer, I really like, of course, your building and your technology. But when we use ultra lightweight building like that, we have two major issues. First is vibration. It's the one you really tackle in detail. But the second one is thermal inertia. So as we have no concrete, I would say in the building, we have a kind of problem with thermal inertia. And how did you tackle this issue in this building?
There is no air conditioning, no cooling in the apartments. Nowadays, it's coming much more in Netherlands, but then not so much. But we used a mechanical ventilation together with a double. I didn't indicate that, but there's a second facade in front, which keeps the heat away from the building itself, from the apartments.
A specific question for Dario about his study, which is an amazing study. I can't wait to see the results. The question is, will you be including a sensitivity analysis within the life cycle analyses? That's two parts to the question. That's the first part. And the second part, kind of following on from something that Don said, and perhaps even Mike a little bit, that we need regulations to drive change to the greatest extent. Would your study perhaps lead to some kind of benchmarking that we could then incorporate as minimum standards to include in our specifications? Sorry, it's quite long-winded questions.
I'd like to answer the second half of your question first about regulation. And I think that in this specific case, regulations are very, very difficult to be improved. It's not as easy as in normal, like during the life phase of the building, your building cannot surpass this specific target of energy consumption because it's very, very project dependent. So we originally were tempted to include the foundations, for instance, but literally the foundation for a building can change from one block to the other. So, for instance, in a building with seismic constraint, you'll have a much, much different impact than in a building with an easier design. So there are so many changes that can affect the embodied energy and the global warming potential of a building that you cannot say buildings have to be within a specific range. It's impossible. What was the first part?
The first part, would you be including a sensitivity analysis? So I'm guessing you use single emission factors, and so would you say let's imagine a scenario where we buy our steel from Turkey with a high recycled content, perhaps made in.
Well, that's exactly yes. So the answer is yes. That's the one of the things that we are studying, and on this regard, the impacts of transportation is quite low. So wherever you can get the materials with a lower embodied energy or CO2 emissions, then the transportation, provided that it happens by train or by ship, is relatively low impact. So in theory, the better materials you can have, the better the project will be.
This morning, in the presentations before the coffee, a lot of the discussion was about concrete and steel and reinforcing steel. Maurice actually started to touch on a few other topics that are of interest, and that is modular construction of some sort and lightweight construction, in particular as it relates to heavy timber or wood products. Let's just say wood products in general. And I'd be curious what the experience and thinking is of the group. Where does modular construction and wood product construction fit in kind of the overall consideration of life cycle analysis and carbon accounting and kind of all the things we've been talking about?
So we've had an effort at SOM to understand what it would mean to build a tall building completely out of timber. There's a specific building that's been identified in Chicago, the Chestnut Building, and a task taken structurally, primarily structurally, but also architecturally, with some industry partners to understand what it would really mean to detail, design, and I'll use the word defend, a completely timber tower. And that research report, I believe, has been published, or it's going to be published in the near future, which is something we're very excited about. What I really like about what Maurice talked about, which is something that we've also talked about, is the infusion of wood where it makes sense. And I think that's a very good approach to it. But the idea of being able to build all of your building, perhaps out of timber, really goes beyond what we might call net zero or very low embodied carbon to sequestration, which is something that we haven't really talked about too much this morning. But the idea of sequestration is that carbon is actually embodied physically. We've been using it in a figurative sense. But if it was physically embodied in the building, then you're actually going to a negative carbon building, which is really where we need to be talking about going. Wood is one way to do that. I think there are other materials out there that need to be considered beyond steel and concrete. I think steel and concrete will always have their place, but it's using them more correctly is maybe where we need to go.
Just a couple of other, and I'm curious, Maurice, about fire. You know, the issue of fire protection, and that's a challenge based on our materials, right? So that's one of the things that we're faced with. Connectivity is an issue, meaning physically connecting, especially in areas of high seismicity. But the issue of fire, you know, so I'm just curious about your thoughts about how you guys solve the fire issue for.
Actually, we solved that in a quite conventional way, you could say. There is so it's an apartment building, so there's a 60-minute separation between the apartments, and the main structure meets a 120-minute demand by how do you call that? Cladding the steel structure. Sorry?
Enclosing the
yeah,
structure.
with a fire protection, a fireproofing. Yeah, I forgot the word. By fireproofing the steel structure, and between the apartments there is a gypsum plate system, a double-layer gypsum plate system, which provides those 60 minutes separation. So it was not really difficult. The difficult part is in let's say, in putting everything together in the same detail. I showed that detail, and everything comes together: the separation of the apartments, and also the fireproofing and stuff like that. That was the difficult part. Yep. And the thing about the wood, using the wood, in Europe we have only 40% of the wood production is used. The other 60% is probably just put back in the wood. So there's in Europe, there's great possibilities to use more wood in or structural or in more for example, facades or just flooring systems.
If there is this high-rise heavy timber building, or Maurice's example, has Enclos or your industry thought about what is the exterior envelope response to this kind of new and unique structural system? Has there been any thought or dialogue there yet?
From a lightweight system?
Yeah, just the notion of how you attach an exterior wall that's compatible with this wood structure inside.
I see no problem with that. I mean, one of the advantages of unitized curtain wall systems. I mean, we also talked a little bit about prefabrication here, which is a big hot item in the construction industry these days. You know, and we all recognize the opportunity of prefabrication, but it presents some significant challenges too that are often subtle, and a lot of the intentions that have been undertaken with prefabrication have run into difficulties. But still, it's complex, but it's an objective. The facade industry has been into prefabrication for decades now with the unitized curtain wall systems, which are basically a modular prefabricated strategy to focus the work in the factory instead of in the on site, where you have the vagaries of climate to deal with and dirt and all those kind of adversities. Higher quality systems out of the factory, but what that drove was a design of systems with the kind of joinery that's involved with the stack joints and the vertical mullions. So you had to separate that. The early systems were stick-built systems. So you had a continuous vertical mullion. You had horizontal mullions that were put in, infill materials. So it's basically all one system. To separate that, to create the modular units, you had to split that vertical mullion and split those horizontal mullions. And what that yielded in the interface was the accommodation of a lot of movement, which has turned out to be a very good thing, right? Because the kind of movement that we have in our tall buildings these days, the curtain wall systems can easily be designed to accommodate that movement. So I don't see any problems at all.
Yeah.
I see a lot of opportunities for synergy with the kind of thing that you're talking about, including potentially the use of starting to incorporate the use of wood in the facade systems themselves too.
Good. There's a project by Thomas Herzog in Hanover. The Messeturme is just a 15-story building, but it has a wood curtain wall system, and there are also a few curtain wall producers that are actually developing wood technologies for curtain walls.
Thank you very much, everybody, for wonderful presentations. We've talked about different factors that affect sustainability of a building. What about the owner factor? Sometimes it takes a certain level of sophistication in the owner to accept what you may feel professionally might be a best solution. How big an issue is that for the practitioner speakers? How well educated the owner is?
It's an excellent question. In fact, of all of our work as design consultants, the owner sets the table. The owner sets the benchmark, sets the rules under which we do our work. And so absolutely the values and the direction where the owner is going to go is important. It's our job as designers to educate the owner on the choices of their systems and the impacts of their systems. But ultimately, the owner is huge in that combination, for sure.
Could I answer? What I wanted to add is that the owner is market-driven. So we should not only focus on the owner, but also on educating the market, because if the market is going to ask for sustainability, and in Holland we see this happening really strongly, so then the owners and also the let's say the more traditional developers, they start to ask us to make sustainable buildings.
One interesting thing that I'd say, at least in our day jobs, in our practice, the client who is seemingly most interested in this topic and in terms of implementing it into real buildings right now is the federal government. Not so much the commercial developers just yet. They're still waiting to see. But the government, in fact, is quite keen to implement this in government buildings. So the GSA, et cetera, in the U.S. is very keen to see buildings get built this way.
I'll add just one other element of what you said, though. I think it's imperative of all of us to communicate in dollars. It's to communicate in the value proposition to the owner. Because if we can't make the financial case for you why you should do something, maybe it's not just first cost, maybe it's over the life of the building. But if we can't communicate to you in the language of which you are working in, we'll have failed at our options.
Hi there, Phil Oldfield, University of Nottingham. I think we've had a really interesting discussion today about the life of buildings. We've had Dario this morning talking about buildings in Hong Kong lasting 13 years, and then Mick talking about facades lasting 1,000 years. So I guess my question is, how do we combat that methodologically and in other terms? end of life is often excluded from embodied carbon calculations because of this idea of uncertainty. If we have a building that might last 50 years, we don't really know what the world's going to be like in 50 years, how much aluminium is going to be recycled, what are the materials we're going to be building with then. So I guess primarily my question's to Dario, but also to the panel. How do we consider what's going to be happening in an indeterminate amount of time?
The starting point of this, I think, is again the market. Buildings can stay there almost forever. I come from Venice, so I can really tell they can stay there forever. The problem is that we are seeing more and more often buildings that are put out of the market just because they look old, or because the business has moved to another part of the city, or because where it used to be an office area is now becoming a residential area. So flexibility, first of all, is the key word to extend as much as possible the life cycle of a building. When you cannot transform and adapt your building, if it was designed to be dismantled, then this becomes an option. I honestly don't want to be the grandson of Donald Trump, who built a 400-meter tall concrete building in downtown Chicago, because that building will be a massive, massive problem very soon. I mean, very soon, in 20, 40, 100 years maybe, but you can dismantle the Empire State Building if one will ever do that. You cannot dismantle the Trump Tower. You have to demolish it, and that's going to be a major challenge.
I have an interesting question for the group that kind of relates to all of this. I often ponder these sorts of things. Who came up with 50 years? Who? I mean, my suspicion is that it was some group that kind of sat around and drank some coffee, and there was no science behind it, right? There was no science. It was a committee number that they kind of haggled over.
And I think they were wrong in any case. I mean,
and why is 100 so much better?
I mean, if you look at the embodied energy, it's like it has a dramatic impact. The service life of the building directly impacts the impact of the embodied energy, right? So, I mean, the question from Philip about the vagaries of the future. I mean, what that speaks to more directly than anything else is that the buildings that we're designing now should be driven by adaptability so that they can be modified to accommodate whatever kind of changing conditions of use or climate or whatever we face in the future. And I think the answer to the question of how long should a building last is very likely to be much different 100 years from now than it is right now. And I think that we should spend some time trying to anticipate what that might look like in 100 years when there's a few billion more people on the planet. And, the vagaries of economics. I mean, I look at the struggle that's going on right now with building owners faced with retrofitting these older buildings. And it's a problem. It's a big cost. The money is oftentimes tough to come by to do it. Are our economies going to be better 50 years from now than they are now? That's a big question, So, it seems to me like we would be, I don't know how we get there, because there is a cost premium up front, and an incremental cost at best, even if we adopt a renewable strategy, right, where we're looking at, I mean, most of the engineers that I talk to, have said that, hey, the structural system should last 200 to 300 years if it's protected properly, and if there is a problem, if it's maintained, it should easily go that long. So, why not start looking at a lifespan in that envelope? And I would say, with monumental buildings, I don't think it's out of the question. And I've started doing this, so maybe you guys tell me, but I don't think it's out of the question to start thinking about 1,000-year service life for these monumental buildings when you consider the kind of resources that are being invested in these buildings.
Bruce Wolfe from Brisbane, Australia. Question really for Mick, I think, but you talked about, I guess, facades needing to be designed for renewable application, if you like. Are you seeing evidence that that's being done? And I guess the second question about towers and their renewability being demolished, are you seeing any evidence that tall buildings are actually taking into account demolition? I know we speak about it, but is there evidence that the people building these super towers are thinking about demolition in due course?
Not at all. The only evidence is that people here are talking about it, which I think is an indicator of a growing awareness of this is a problem, and I think it's likely to change. But with facade systems, that's specifically what I'm talking about. I think we're building more problems for our future right now. The way that we're doing things, we're not designing to accommodate the future requirements that we're likely to see that we can identify actually right now.
Well, it is really, I think, an interesting conversation. I think it brings to mind something that as structural engineers we face all the time, and that is increased knowledge of conditions. And let's think about seismic conditions, for instance. So in the last, let's say, 40 or 50 years, what's happened? Well, we've understood more about the behavior of buildings and site conditions and so forth, and what have we done? Well, we've either taken buildings down or we've retrofitted them in a way that's a bit of discovery as we get into these buildings, and we learn more about site conditions that have not been anticipated. So could you imagine us thinking about those systems in advance? Because we're going to learn more. We're going to learn more about San Francisco. We're going to learn more about Tokyo. And you wonder about these systems, whether they're structural systems or exterior wall systems, and should we be anticipating future change? And how would our buildings accommodate that? It's a really tough question, because you sort of think about, the bigger earthquake, right? So how would those buildings respond? But it's not just a bigger earthquake. It's other things that might impact. It could be tsunami. It could be whatever those environmental changes are. So it's a challenge. I don't really have the answer to it, but it's something really worth thinking about. And when we talk about adaptability and future use and what's to come, because we can't admit at all that we've got it all solved yet, right? It's just going to be continued research, continued knowledge as we go along. So anyway, it's kind of worth thinking about.
I think these are all design problems. Sustainability is a design problem, and what all you guys are doing is working on providing the information that is required to produce good design, right? That's what you're talking about doing. You at S1 with your tools, Dario with your research. It's really important stuff. It's stuff that the designers, the architects need.
The only other thing I want to put out there on time is there's many unknowns, many things we can't predict, but functional obsolescence, as we're talking about, the economic life of a building, usually is driving the condition much more than maybe the structural surface life. I think about stadiums as an example in the United States. 20, 25 years, typically stadiums are being replaced because they don't have the right suites, they don't have the right configuration from a functional obsolescence. But if we know in advance that this building is only going to be up 25 years and it's going to be taken down, it's even more important to think about, let's put in a building that's designed for a 25-year life, that is actually able to be disassembled, that is maybe more fabric or structures that actually are based on the surface life of what they're going to be. I just think it's an important part that comes to it. Also, just on the stadiums, I think it's interesting the infrastructure that gets us to some of our significant buildings. It could be a high-rise building, but I'll use the stadium as an example. The transportation networks that get us to a site to allow for these facilities, even if they are going to change over, rebuild it at the same location, because I think the infrastructure that goes in and around some of our major buildings, and if we decide on whether it's dense urban environments or stadiums or sports complexes, rebuilding at the same location can be as significant of a sustainability element as the building itself.
I think this, Anthony Wood, CTBUH, I think this issue of how long we design buildings for, and Phil's question's a really interesting question. And I hate to be a doomsayer, but I wonder if it stops at buildings, yeah? I mean, I wonder if actually there's going to come a point where we need to be strategic about where we concentrate our cities. Yeah, with climate change and other things. So it's interesting to hear about this abandonment of buildings, because the gravity of economic gravity of a city might change. But I remember Peter Rees speaking at our conference in 2008, London a sustainable city, because the location of London, the climate's not so extreme, the access to natural resources. And sustainability, I think, is still a question of choice and not survival. And when sustainability moves from, or climate change moves from choice to being a matter of survival, I wonder whether we're actually going to have to abandon some of these cities, possibly even New York, and get more strategic with, and so the 1,000-year life, this. So I don't think we're even thinking on that level. Maybe we don't have to, but if we did, then that changes the whole equation again. I wonder what the panel think about that. Probably think I'm crazy.
I think I just heard you set up a panel discussion for the next conference in New York.
Newsflash, Anthony Wood says New York is going to be dismantled.
That'll hit front page of all the papers. That's where you like to be, right? No, I think it's a fantastic point, and I think it's exactly where we need to go. This kind of thinking drives perception. It will change the way that we think about our buildings, the way that we think about designing our buildings. The whole deal. I think it's a really important thing, and I think that CTBUH can play a role. To me, it really is much more important than defining what differentiates a tall building from a super tall building. To put some solid information out about what makes sense in terms of building service life and major building system service life.